Hello, brothers and sisters. How are you doing? My name is Michelle, and I'm going to be reading from Jim Stevens' book. It's 101 Proofs for God. Yeah, so I had to really study before reading this particular chapter. It is chapter 16, and it's called The Brain. All right, so let's get to it. There is way too much information on the brain for me to cover in a short chapter, but I want to give some convincing highlights, probably more that you want to read. Here is a quote that will get us started. Scientists claim that the most complicated and mysterious thing in the universe is the human brain. Scientists know more about stars exploding billions of light years away than they know about the brain. The brain is a vast mystery, and our greatest scientists have not figured it out. That makes a great case for me that it must have been created by a higher intelligence than ours. To think that it happened accidentally when our greatest minds are very far from understanding its complexity is preposterous. Accidents do not create order. The human brain consists of approximately 100 billion neurons. That, by the way, is about how many stars there are in the Milky Way galaxy. Each neuron has somewhere between 1,000 and 10,000 synapses, equaling about 1 quadrillion synapses. Some say there are up to 40,000 synapses per neuron. There are possibly as many connections in your brain as there are stars in the known universe. My goodness. If all the neurons in the human brain were lined up, they would stretch 600 miles. A piece of brain tissue the size of a grain of sand contains 100,000 neurons and 1 billion synapses, all talking to one another. That is just a piece of your brain tissue the size of a grain of sand. Human brains are comparable in computer power to the world's greatest computers, but fantastically better at almost every other task while fitting inside your skull and using only the power of a small light bulb. And in quotes here, the world's most powerful supercomputer, the K from Fujitsu, computes 4 times faster and holds 10 times as much data. And of course, many more bits are coursing through the internet at any moment. Yet the internet servers worldwide would fill a small city, and the K sucks up enough electricity to power 10,000 homes. The incredibly efficient brain consumes less electricity than a dim light bulb and fits very nicely into our head. A human brain is 75% water and has the consistency of tofu, custard, or gelatin. You could cut it with a table knife. Note also that the human brain accomplishes everything at a relatively slow speed, nothing like a computer. Impulses travel only about a little bit more than 200 miles per hour. Axons, the long output connection from a cell, come in two types: myelinated and unmyelinated. Myelinated axons have an extra layer of insulation, a fatty substance, which allows the impulse to travel about 10 to 100 meters per second. Unmyelinated axons only transmit at about 1 meter per second. When the signal reaches the end, it has to cross the synapse to influence the next cell, which adds about 5 miles. 5 meters, excuse me. 10 meters per second equals 22, just over 22 miles per hour. 100 meters per second equals just over 223 miles per hour. So your brain impulses are moving really slow compared to the speed of light and the speed of computers. The speed of light in a vacuum is exactly 299,792,458 meters per second, or we can say 186,000 miles per second. Light goes at about, get this, light goes at 670,616,629 miles per hour. A 20-year-old man has around 109,000 miles of myelinated axons in his brain, which is enough to wrap around the Earth's equator 4.5 times. Here is an amazing fact. 3-year-old babies have twice as many connections in their brains as adults. Babies are born with around 100 billion brain cells, but only a small number of neurons are actually connected. By 3 years of age, a child's brain has formed about 1,000 trillion connections, about twice as many as adults have. At around 11 years old, the brain begins to prune unused connections. Connections that are used repeatedly in the early years become permanent. Those that are not are eliminated. There are more than 1,000 chemical reactions happening in the human brain every second. The human brain has around 100,000 miles of blood vessels. 750 to 1,000 miles of blood flows through your brain every minute. That's enough to fill about 3 full soda cans. In 2001, researchers from Harvard found that certain parts of the brain were differently sized in males and females, which may help balance out the overall size appearance. The study found that parts of the frontal lobe responsible for problem solving and decision making, and the limbic cortex responsible for regulating emotions were larger in women. In men, The parietal cortex, which is involved in space perception, and the amygdala, which regulates sexual and social behavior, were larger. Here is a quote from Jeff Hawkins about computers and brains in his 2004 book on intelligence. A human can perform significant tasks in much less time than a second. For example, I could show you a photograph and ask you to determine if there is a cat in the image. Your job would be to push a button if there is a cat, but not if you see a bear or a warthog or a turnip. This task is difficult or impossible for a computer to perform today, yet a human can do it reliably in half a second or less. But neurons are slow, so in that half second, the information entering your brain can only traverse a chain 100 neurons long. That is, the brain computes solutions to problems like this in 100 steps or fewer, regardless of how many total neurons might be involved. From the time light enters your eye to the time you press the button, a chain no longer than 100 neurons could be involved. A digital computer attempting to solve the same problem would take billions of steps. 100 computer instructions are barely enough to move a single character on the computer's display, let alone do something interesting. I'm going to turn the laptop a little bit because I'm not sure it's bright enough. Let's go like that. Okay, see, that's a little better. It's a little bit lighter. Let's keep going. Even if humans compete against single-minded computers on a particular task, we have to remember the human brain is doing thousands, if not millions, of other things at the same time. Millions, if not billions, of nerves throughout our bodies are sending signals to the brain for processing. Your eyes, your ears, your heart, your lungs, and all your other organs, your muscles, well, just about everything is sending messages to the brain. The more we discover about the brain, the more wondrous and awesome it is. If you think that computers are even remotely close to being like a brain, do some research like this article, Brain versus Computer, on lucidpages.com. So far, the phrase from this book, so far, no research team has been able to pinpoint where in the brain memory is and how it functions. Here is a little bit of information on how synapses work in the brain. This should leave you awestruck. Neurosynapses in the human brain are extraordinarily complex structures responsible for relaying information between neurons. Chemical synapses govern the release of over 100 different kinds of neurotransmitters, while electrical synapses deliver information via electricity for rapid fire reflexes. When a nerve impulse gets to the end of an axon, its message must cross the synapses if it is to continue. Messages do not jump across synapses. Instead, they are carried across by chemical messengers called neurotransmitters. These chemicals are packaged in tiny sacs or vesicles at the tip of the axon. When a nerve impulse arrives at the tip, it causes the sacs to release their contents into the synapses. The neurotransmitters diffuse across the synapses and bind to receptors in the membrane of the cell on the other side, passing the signal to that cell by causing special ion channels in the postsynaptic membranes to open. This setup is awesome. There is a tiny gap between all the connections of nerve cells. Complicated chemical processes have to take place in order for the message to be transferred from one nerve cell to the next. Not only is it complicated to send a signal, but there are also mechanisms in place to stop the chemical reaction. If it were not stopped, then whatever message was sent would continue to be sent. If you had wanted to raise your arm, it would keep on rising and never stop. Why the gap between neurons? It absolutely has to be there, because if all the neurons were connected without a gap, then when one fired off, they would all fire off. It would be like wiring all your electrical circuits in your house to one circuit, no individual on and off switch. When you turn on the lights, they would all go on in the whole house. Try to imagine if all the nerves in your body were firing at the same time. This sounds a lot like my 9-year-old. Total chaos. He's actually 10 years old. See? He drives me nuts. Can't even remember his age. As you can imagine, I'm just getting started. Hundreds of books have been published on the brain, and thousands more will be. I have even read where some people now believe that your memories are stored in all the cells of your body, not just inside your skull. People who receive heart transplants are also receiving memories and habits of the former owner of the heart. Our existence is a total and absolute miracle. Only a supernatural cause could possibly be an explanation for our existence. No materialistic cause, and certainly not a materialistic random accident, please, makes any rational sense whatsoever. So there must be God. Wow. Yes, this just so amazing. I have no words. Yes, thank you so much, Jim, for this. So anyways, thank you so much for listening. You have a ton of food for thought. So the next chapter we're going to be reading is chapter 17. It's called Dr. Anthony Flew. Okay. All right, well, thank you very much, everybody. I hope you have really nice weather where you are. Get out and enjoy it. Okay, take care. Bye.